Ready?
Yes.
And action. Oh, we have props.
Don't think I'm going to be a producer anytime.
Okay, so hello everyone and welcome to DevOps Topics episode God knows who 40 something.
47. I went
47.
ahead and
Omer is
checked.
responsible, he's checking these kind of
Yeah.
things. And today we are going to talk about monitoring Kubernetes nodes, CPU, and memory.
So I
Should
have
I
another
even do
prop for
that?
you. If
Yeah,
if
go
if
ahead.
there's going to be a visual to this
There's gonna be. Okay, so so Omer presents a Kubernetes wheel.
it's a helm.
It's a helm, yeah.
It's a helm.
Okay. Okay. So again, the topic today is Kubernetes. Should we monitor nodes for memory and CPU? Should I even do that? Okay. Do I want to do that? Shouldn't I? Or maybe yes, maybe no. So Omer,
Yes.
what's the first thing that comes up to your mind when I say, should I monitor Kubernetes nodes, CPU, and memory?
You want me to be 100% honest?
100%. What's the first thing that comes up to your mind?
Okay, so short answer yes, but the long one is me wanting to ask you in return, what
Hmm.
exactly are you monitoring in your cluster? Fine, you probably have something. I'm guessing you're monitoring CPU and memory over your pods. Beyond that, what are you monitoring in your cluster?
Tons of applicative stuff. But wait. Let's not kill the format. I want to hear
Okay,
your thoughts. I want to hear it.
right.
So we'll do the retort, we'll revert
Yeah.
questions in a second. So what's the first thing?
Okay, so
Should I do that?
yes, easy answer. Do you want me to expand a little bit?
Yes.
Okay.
Yes.
Um, Very short background. The entire idea of having a cluster is us having applications packed into containers which run in pods, and these pods are then assigned to nodes because this is literally the metal that it's running on. Right? With no nodes, there's no cluster unless you're using some kind of technologies like Fargate, etc. That's not the case. When we run the nodes, these are the hosts for the applications. If you don't monitor them, you're going to get into weird edges of the platform. Now, you may say that, wait, I'm monitoring my pods. They are moved around. There's a control plane on top of the cluster. It moves pods around. Everything is okay because I have limits. The pod knows, the control plane knows how much CPU and memory the node has. It will only place things that are responsible, quotes unquote, to put on that host. And it will always manage the buffer, which I'm going to say not 100% correct. This buffer, first of all, not always is actually calculated. And when it is, the control plane doesn't always know what's going to happen. And another short bit to my answer is there are a lot of things running on your node beyond these pods. For example, kubelet running processes, more agents that as your cluster grows, especially in large production environments, if you work in in hardened security environments or just security companies, you have so many agents running on your node for so many reasons: monitoring, security, controlling transport, encryption, mesh, like network mesh, stuff like that. You get a ton of agents. You have a lot of load on stuff that are running on the node. I think that for this reason, you need to monitor your nodes, at least from some point.
Okay,
This
that's
is
going to
my
be
this
super
is my short
interesting
version.
because today we are going to fight.
Okay.
Okay. And by the way, this episode is dedicated to Tamir Greenberg, who told me, come on, man, where is the next episode? And also to Liran, my team lead, that we talked a bit about it, but we didn't really dig too much. And we also agreed. But today, I don't think we are going to agree, you and I. So I really want to fight with you today. Okay, so this
Okay.
is your short version. My
Yeah.
short version is when this comes up to my mind, I just say node exporter. Like if you tell me monitor Kubernetes CPU memory for nodes, I just think node exporter. But Omer, what is node exporter? What am I talking about?
You're talking about the bit that connects to Prometheus and adds the relevant node metrics.
So wait, maybe we have some viewers that don't even know what's node exporter. I mean, like you're talking Prometheus. Don't throw out buzzwords. Maybe can you explain what is node exporter?
So you'll have to complete me. But basically, Prometheus is the go-to monitoring system for Kubernetes. It's essentially a time series database that is the default method is go and scrape other applications on the cluster, usually to slash metrics. It collects bits of metrics on different time points, usually every second, every 5 seconds, every minute. And based on that, it builds a graph. And then on top of Prometheus, which is a time series database, you can either visualize things, create alerts, just debug, or put another thing on top of it like Grafana and build additional visualizations and metrics and alerts and stuff like that. And the node
So let's start
exporter.
with the basics. Yeah. So
Okay.
let's start with the basics. Just like what you said, I want to build it up. Okay. So node
Yeah.
exporter can be like Omer exporter, Mer exporter, or whatever exporter. This is a process that is running on the node, right?
Mm-hmm.
Like it's a container that is running on the node.
Yeah.
What it does, it gives you information about what you want to know. If you want to know about the node, you'll probably use node exporter. If you want to know about an application that Omer built, you'll probably create Omer exporter. So
Mm-hmm.
this is like the exporters level. After that, we'll use what you said, Prometheus.
Yeah.
Prometheus is going to scrape those exporters. So you have this Prometheus YAML where you can define the jobs and whatever, where you can scrape your exporters. Okay, so now we're building it. We got the exporters level, then Prometheus scrapes those exporters. And on top of this level, we're going to use what you said, Grafana for visualizations. We can have maybe other tools and stuff, but we're talking about like the most famous stack probably. So we can use Grafana to visualize what Prometheus has scraped from the from the exporters, not just node exporter.
Mm-hmm.
And in Grafana, you can also use alerts, as you mentioned, Omer, or you can also integrate Alerts Manager. But we're not going to talk about that. So we're only going to talk about exporters and Prometheus a bit, and maybe Grafana, I'm not even sure. But now we're going to focus on the layer of exporters. So we're going to talk about node exporter, where a container runs on the node. By the way, Omer, node exporter is a special exporter. Can you maybe even think why am I thinking that it's a special exporter unlike other exporters?
Because
Why
it's
is
a
it
daemon
special?
set, because you have to run it.
Because you read my mind. Because it's a daemon set. But what is a daemon set, Omer?
So a daemon set is a Kubernetes component that ensures you have exactly one of each on every node, usually for agents, log collection, metrics collection, etc.
So why do I need it for node exporter? I mean, like the answer is like probably in the question, but
Yeah,
but
again, you want to monitor the node. If you have two, you'll get double the metrics. If you have none, you have an unmonitored node. So essentially, you need exactly one of each on every node. But then
so
I
as
have
a rule
a
of thumb, it's good to
yeah,
have node exporter as a daemon set.
exactly.
Okay.
But then, okay, so you're telling me I don't need to monitor my nodes because I have a node exporter that sends the metrics to Prometheus, so I'm already covered, right? Is
Yeah,
that your claim?
I even say hang on with that. Either way, I say you should monitor them.
Mm-hmm.
Later on, I will argue with you that I don't want to have alerts about it.
Okay,
Okay,
all
that's
right.
my argument that you
You don't
don't
want
need
to
to
have
get alerts.
alerts.
Alerts about monitoring my nodes, CPU, and memory. I don't care about it.
Okay,
Like even if they
interesting.
get to 90%, I don't care.
Okay,
Okay.
yeah.
So that's my argument for later on. Hang on, we'll get to that. Okay, so I
Mm-hmm.
think we have the basics, like we covered the basics. Exporters, Prometheus, Grafana. Node exporter, we should run it as a daemon set, which runs on any node in the cluster. So we have information about the whole cluster, about all the nodes in the cluster.
Yeah.
Okay, finally, we have everything up and running and set. And now we are moving to the alerts. Now, let's talk about the alerts in general, because Omer, you love this area.
Mm-hmm.
When I say alerts, what do you want to get alerted about in the
Uh,
concept?
yeah. Okay, so it's another philosophy. I like to get alerts only for things that are critical for me to know about and that usually cannot fix themselves, or there's a risk in the process of them fixing themselves. For example, if a node just hits 70% CPU and it happens twice a day, every day, I don't care because I'm assuming something is going to manage that load and it's going to go down. However, if a disk pressure gets to 95%, and it's super critical, I'm assuming it got there because there's an issue. It's probably not going to resolve itself because
What is
it's.
disk pressure, Omer? Maybe someone doesn't know. I don't
So
know.
without going too much into details, let's assume there's something wrong with the storage mechanism of the node. And especially with Linux systems, when you get to disk pressure in a way that is not, when the disk is not functional, nothing's functional. Nothing can be written. Linux is all based on files, so nothing can be written or read or function at all. So at some point, if your disk is full, like the main disk, the default one, is the operating system is disk is full to 100%, you cannot SSH into the instance. Nothing will work. So disk pressure that high in the level, I probably want to know. There's a term I think we talked about a lot that's called alert fatigue. If you when you start monitoring, you are so excited about all the possibilities and you can visualize everything, which is great. But if you start alerting too much about too many things because you're super excited with your shiny monitoring system, then I'm speaking from experience. I got so many alerts that it was bothering, right? And so maybe I didn't mute the channel because I was responsible for it, but any other developer that was relevant to that channel muted it right away and ignored everything altogether. So you want to alert on certain things that you really have to know, and in a good manner.
Okay, so I wanna like purify what you said and take exactly like I hope I'm not killing what you said, but I just want to
Mhm.
take like a fraction of what you said and say that you want to get alerts about things that are not good at self-healing, and you want to make sure you do it by yourself. So it's like you want to get alerts only about things that you can actually do something about, if I can say
Do and
that.
should. It's both.
Do and
Yeah,
should, yeah,
can and should.
but because the self-healing mechanism is probably not that good, and as you
Either
mentioned,
failed or non-existing. Yes.
the disk pressure, maybe disk pressure I can just or maybe disk usage, maybe
Yeah.
the disk is getting full, so I can just enlarge the disk, if it's an EBS
Let's give an
problem on
example.
AWS, or
Okay.
sure.
Uh, Other than misconfigurations in Kubernetes, one of the reasons that this can get full is because a load of
Logs, tons of
logs.
logs.
But again, logs should clean them. Okay, logs, cool, good example. Same as what I had in mind is images, because container images usually tend to blow up, and especially if you don't build them right and you store too many, then you have a lot of images stored. It can get to multiple gigabytes. Now, every container runtime has its own garbage collector, which will run at some point and clean the images. But it might either fail, not run frequent enough. You may have like a 5 GB, for whatever reason, for 5 GB image that is clogging everything. Your disk may blow up. And if it happens, look, if it happens in Kubernetes on one node, it can happen again and again and again because that image belongs to a pod, sorry, that can move across the cluster. So it's something you want to know about. That's just one example. Same with logs, like you said. Logs blow up. It might be something from the node. It might be something from a pod that has debug mode on and is just blowing up everything because there are
That's
a
a
few
classic one,
instances.
what you said, like having a pod with a debug on can do so many interesting things in production.
Yeah,
Like,
yeah, and
many
especially,
interesting things.
and you have to remember that with Kubernetes, the nature of the application is to move around the cluster. So you can literally sometimes chase it. Like you're going to chase a rabbit around the cluster, and it's going to fail here because the disk died, and it's going to start there and then fail again. So it's sometimes hard to catch. So
Can
you
you
want to catch
explain?
this.
Okay, so let's specifically. So we'll have a chapter, not a chapter, but a subject about it, like the pod eviction. What you just, I like what you said about chasing it. So if like a pod is set with debug equals true,
Yeah,
and you're trying to find the problem, and you realize that you can't find the problem. So can you talk about maybe the pod eviction
yeah.
process? It sounds interesting.
Okay, so that connects to the first thing I said. The entire idea of having a cluster of any kind, not just Kubernetes, is the notion of having a bunch of servers that you don't need to manage. It's just a bunch of server, like an instances with something that tells Kubernetes, "Hi, I'm a new node, just use me." And then Kubernetes does all the hard or heavy lifting of taking different applications and placing them across these nodes and moving them around. When something fails in a specific node, for example, disk pressure, high CPU, something's not functioning, the node cannot work anymore, either at all because it's completely malfunctioning, or it got to a point that things are hard to move, then Kubernetes is in charge to monitor these things and move stuff around. Eviction is usually the second part, where things are still working, but Kubernetes understands that they might not keep working if the same thing keeps going in the same direction. So it slowly moves things around. Slowly, as in gradually. If you have a front end application and you have three instances of the same application, Kubernetes will slowly take one, move it around to another node and then slowly take another one, both to ease the pressure on the node, but at the same time keeping your applications up and running so that customers can still use them.
That's a bad. It's funny because that's like a bad self-healing mechanism. Because what you're talking about sounds like cancer. If you think about it, you have this radical pod
Mm-hmm.
who can bloat, who can blow
Yeah,
away with logs the
yeah.
instances, and then Kubernetes says, "Listen, this is full. I'm going to move you to a new node." All right, it moves you to a new node like cancer, spreading the cells, and
Yeah.
then it's gonna kill the new node, and then it's gonna say, "Wait, wait, hang on. It's not enough. I'm going to move you to another node." So the pod eviction can
So wait.
eventually destroy a whole cluster.
Exactly. So the second part of this is just normal behavior in a cluster. Now the other part where you're talking about is if you have a pod that's actually, it is so bad to a point that it kills the node it sits on. It kills the host, which is exactly like a virus, right? A virus
Kills
is
the
something
host.
that it is what it is. It's a
It's so
biological
real.
virus that, yeah, it kills the host. It feeds on the host, right? It uses resources. Like if a virus in a biological person would feed on the body, kill it, and then move to another host. So exactly like a virus, so it would kill it. And to be honest, we're describing a cluster virus. So it either bombs logs into the disk, it either consumes too much resources. It's what you call in a cluster a noisy neighbor, but a very noisy neighbor to a
Oh no,
point
I'm
that,
trying to think while you
yeah.
talk. I'm trying to think if that happens to me. Like I don't even, let's say not in production. Let's not take it to production. In QA,
Mm-hmm.
I'm embarrassed to say that I don't have any amazing idea about how to. Well, of course, I can roll over, roll back to a previous version or change the environment variable or whatever. But I mean, I don't have or know a self-healing mechanism that can deal with this kind of thing. That like I can't think of something like this up in my mind. Like if you are doing something wrong, roll out to previous version or something. So maybe over here we'll need an alert about like restarts or something. So if the pod does many restarts or disk pressure, so this is where the alerts come into hand, right? Because the self-healing mechanism is not good. It's gonna kill the whole cluster, right?
Let's put it in simple words, because where you're going is exactly what I think every one of us experienced engineers would think. But this opens like a range of possibilities. But I
Yeah.
think if we put it into simple words, the notion of having something went wrong, let's pop an alert because the configuration is not working well, and you as a human should handle it. Otherwise, even if the disk blow up and the CPU is too high, air quotes, if you've configured everything properly, it'll work. It'll find a way to fix things. I mean, sure, the application is consuming too much memory and CPU. Something's wrong with the application. It won't kill the node or the cluster because you've configured it properly. Now, in this case, by the way, you do want to know about it. It might not kill the node. It won't hurt the cluster, but the application in it, like the application itself, would fail because it's blowing up. Maybe it has a memory leak or something like that, and you do want to know because you need to handle that specific application. That's important. No, one term that I always forget and I wanted to mention here, to not many people are aware. Do you know what a service? It's a disruption budget, an application disruption budget. You know that in Kubernetes,
Yeah, I heard.
right?
Yeah, yeah. It's a kind. It has its
So
own
it's a
kind.
CRD, right? So
Yeah.
it's a new API. No, well, not new, but it's a CRD that you can configure in your cluster. Most people don't configure it, but basically it tells Kubernetes, this is my application. This is how much disruption I can suffer. Why is it important? Imagine having, again, a front end application that serves customers, like, I don't know, a retail store, and you have 4 different instances across the cluster, and that's serving your customers. If for some reason you need to now, I don't know, run a rolling update on the nodes, or evict some of the nodes because you've upgraded your cluster version, or for whatever other reason pods need to move, then you have a budget that tells Kubernetes this app can survive if you remove, I don't know, 30% of it. Then it will calculate every time something goes wrong and pods needs to move around, it'll calculate how much disruption budget you allow for, and act accordingly. So that's just something nice to remember. Most people and most clusters, as I've seen, never configure these things, but it's very important and it's very useful.
So thank you for the tip. Sounds amazing. Sounds like the good self-healing mechanism for our virus. Our rogue pod
Yeah.
that is roaming the cluster. Getting in the cluster and sings Metallica. Everywhere I roam. and then just kills every node each time. Okay. So now that I think we got to the point where I want to fight. So far, I think we agreed on a lot of things. We learned tons of things. So let's get back to the beginning. Why we came to this episode? Like, should we even monitor or get alerts? Okay, about nodes, CPU, and memory, like high memory. Do I care about it? So, my opinion is, Omer, no. But an asterisk. Okay. Side note, if this node is a spot instance or a node that I like, it's not an on-demand node. It's a node that I know that can die from time to time. It's even in production. If it's a node that I don't care, it doesn't have to be steadily running all the time. It can simply die from time to time, which is okay by me because it was by design. Then I don't care if it has high CPU or high memory because it's doing what it should. And I'm not saying don't monitor it. I'm saying don't get alerts about it, probably, because it will make more your, how you called it, alerts fatigue. So it
Yeah.
will destroy your alert fatigue. Now, what do you have to say about this? This is my opinion. I didn't say why. I didn't say, like, I didn't give like a good explanation of yes, no. I just said my opinion. What do you think about that?
So to frame your question, just to make sure that we're on the same page, you're
Yeah.
saying you have the node exporter, it's already doing its job, you're getting the metrics, you don't have to have alerts over it because the node might have issues, and that's okay because Kubernetes will handle it. Surely not a reason to monitor anything further, like beyond the node exporter. Let's just live with it and Kubernetes will deal with it. That's what you're saying, right?
Yeah.
Okay. So
That's the explanation behind what I said.
yeah, I'm sure. I'm not just framing the question. So
Okay.
I'll be the annoying engineer. I'll put the annoying engineer hat here,
Yay.
and I'll put the Pareto law into action. So 80% of the times, and probably in this case 95% of the times, you're right. It'll be okay. We can talk about whether to alert or not later on. But essentially, if you have a node exporter doing its things, you get most of the metrics you need. You're okay. You're good to go. However, at some point, like I mentioned in the beginning, you're going to have too many agents and too much load running on certain nodes, up to a point that sometimes your node exporter, even though that it is a daemon set running on each instance, can actually blow up or crash, right? And when the node, it's just an application on a cluster. Sure, it's a daemon set, nice, but the daemon set doesn't mean it's more robust. It just means that you have one of each on every node. It runs exactly the same controller, the controller manager that takes care of all the other applications, in the same manner takes care of daemon sets. It makes sure you have one, but it's just a controller. If that fails or the daemon set fails, it's just a pod. And if that pod fails, you have no alerts, no alerts, sorry, and no metrics over your node. And for that reason, I think it's important to also monitor the. It's funny to say, but it's under the hood. Not really under the hood, but if you're running on GCP or AWS, monitor the server itself just to see what's going on. You're asking, okay, but do I need to get alerts over 70% utilizations? Probably not, because it's not the same as other applications or servers. But if you are getting to 90 plus, then something might go wrong. So maybe my answer, if I'm trying to,
Talking about the node
yeah,
specific, not the pods,
yeah,
not
yeah, yeah,
anything.
just a node, just a node.
So
So I'm,
if
I'm
if
trying
a
to
node,
reduce.
so now I'm gonna ask you a simpler question.
Well, so just to sum it up, one sentence. I think if I'm reducing the entire idea,
We are so excited.
because I want to say you do need to alert. That's my point of view. You do need to alert, but the levels would probably be much higher, right? Because you only want to know if something goes really wrong. Maybe that's the
Okay,
reduction of everything. Yeah.
okay. I still have my simpler question.
Hmm.
What are you gonna do about it?
Sorry.
What are you gonna do about it?
What am I going to do about it? Okay. If I got to first of
So
all,
wait, just to make sure our viewers are on the same page.
yeah,
Omer set everything right. Set in his cluster, he's got the node exporter, Prometheus, Grafana. He set Grafana to alert him when the node utilization of CPU or memory, I don't care, was if it's more than 90%, send Omer a Telegram message, email, whatever.
yeah,
Omer saw the alert.
yeah.
Now, what does Omer do?
Let me give you a real life example. Maybe that'll help. my day job is building controllers, specifically today, controllers that handle basically storage for applications, mainly around stateful set, things like that. To someone who's listening doesn't know, like a daemon set, stateful set is another kind in Kubernetes that you mainly run for stateful applications. It's important because you want to have an application that has a disk, and that disk is probably attached to a node, and you want to make sure that every instance of that application keeps, if it dies, it keeps, or if a new one starts, it's starting its runtime in the same node because the disk is attached there, yada yada. Cool.
But
Um,
wait, a stateful application, it's important to say because we learn by examples, can
yeah,
be a database, Redis,
yeah,
MySQL,
anything that
Postgres,
requires a
or
storage, yeah, exactly, that would
okay,
use a
moving
stateful
on.
set. Cool. So we're building a controller. Now you might say, cool, your scenario is a bit different because you're building something and it's in dev mode, etc. However, again, you're going to install so many things as time grows in a cluster, for example, with, let's talk hundreds, thousands of nodes, things get complicated. And not only regulations, but you need help, like automatic help to manage different stuff, costs, resources, utilization. You're going to add more and more daemon sets and agents on the node or on the cluster. And we got to a point where it's in dev mode, but our controller was blowing up everything to a point that the server was not usable at all. And if we didn't have metrics, like raw metrics coming in from AWS on what's going on with the node, we'd never discover it because things were just failing. So we'd keep, well, I think the idea with DevOps and monitoring generally, you are going to find a problem at some point, but the difference between finding it in the first 5 minutes to a week of chasing your tail and being frustrated about it and using more and more resources and more people to find out the problem is how you configure stuff. At some point, you're going to solve it. You can destroy everything, right? You can kill production and restart
Omer, my
everything.
question stands still. I need an answer to my question.
Go ahead.
I understand your use case about the controllers, but my question, I'm gonna be rough about it. My
Mm-hmm.
question stands still. Omer set everything right. He got an alert about 90% of the node CPU or memory
Mm-hmm.
on a node that can be killed,
Mm-hmm.
okay, on a spot instance on AWS or whatever, in EKS,
Yeah.
right? What does Omer do after he sees the alert?
Cool.
What do you do?
So my answer, my direct answer is it's not always about me. It's not. I can't always. Again, with the agents, I'm going to have a lot of third parties running on my cluster. If I got an alert that something keeps dying, a node keeps dying because it hits 99% CPU. Let's go with a real example. Something's wrong, right? It's not something that's going well in the cluster if a node keeps dying over 99%. It's not, even though Kubernetes can handle nodes dying and pods dying and stuff like that. If this keeps happening, if it's a recurring event, something goes wrong. What am I going to do about it? I'm going to find why my node dies out of 99%. Maybe it's a bad controller, a bad daemon set, an application. You started by saying you configured everything properly. Now we can talk about what's configured properly means. You probably meant about resources, using limits and stuff like that. Assuming you configured everything right, things can still go wrong. An application can still make use of the fact that you didn't configure a limit for your CPU because that's the right thing to do, but it was abusing that because it was what we mentioned earlier, a noisy neighbor, which is not normal, but exactly that's the point. If something keeps dying, something is abnormal in your cluster, I need to fix it and I need to find the noisy neighbor and make sure that it's not a virus that keeps moving across the cluster and kill it or reconfigure it or uninstall it. Is that
Okay,
an answer?
I will answer.
Yeah.
It's sort of an answer
Yeah.
because your answer has a hidden it depends, as we always say. So I'm going to answer like again, simple question, simple answer. I'm gonna say I'll take my phone because I got the alert for 90% of my node. Oh my god, it's crashing, it's gonna crash. I'm gonna look at it, I'm gonna say, okay, why did I set this alert? Whatever. I'm just gonna put away my phone and move on with my life, even if it's production. If it happens again after, I don't know, 10 minutes, 20 minutes, as you said, a recurring event, so maybe then I'll start thinking something is wrong. But if once in a while, let's say once every few days, once every few weeks, I don't know, the one of the nodes is getting, CPU limit to CPU memory or whatever to 90%, I'll be like, okay, it's doing what it should do, as long as it's not crashing all the time and it gets so high or to those numbers, I'm fine with it, because this is why I'm using Kubernetes. This is why I'm using AWS EKS or GCP, GKE or any other cloud, because they know how to kill a node if it's not functioning. If you get to the node pressure or node starvation or whatever you call it, and that's it. Why do I need to intervene, or why do I need to get an alert about it? Unless it's a recurring event, every 5 minutes, every 10 minutes, all the nodes in the cluster are getting crazy. I'm talking about, like, when you suddenly get an event in Slack or your channel or in your phone. What am I going to do about it?
Okay, let's start with the fact that when you configure just alerts, they need to be smart alerts. Even with Grafana, any kind of alert mechanism on AWS, GCP, you can configure your alerts to only pop when this thing is recurring, like twice in 5 minutes, or twice in 10 minutes, or 3 times in an hour, or whatever. If something pops once in a day, it may have a sense to pop an alert over. If you have an alert that has nothing to do with your life, you said, I'm looking at my phone and now I'm flipping it over and I'm moving on with my life. It doesn't mean that it's a bad alert, because sometimes you want to have alerts just to know the context of what's going on. You're not living in Grafana. You don't see the dashboard the entire day. So if something does go into a high level, you might, as a DevOps engineer, again, not as a developer or a team lead that's his application, but as an engineer who's in charge of maintaining the cluster, you might want to have a context of what's going on. So you want to keep in the back of your mind, okay, my cache instances are in very high memory levels at this point. I just need to keep that in mind in case something else happens, because in an hour something's going to go wrong on another place, and maybe that has relevance because, that app is using that Redis that I got an alert over an hour ago, and I did flip my phone because it wasn't critical, but maybe it has to do something with it, so let's go check. So you need these alerts for context. That's one thing. The other is, if you're getting a critical alert that simply has nothing to do with your life, it's just not a good alert, you need to reconfigure that. If something popped, again, like you said, once in a day, usually not a bad idea. A good idea not to pop an alert over. But if something is recurring, you do want to know about it. And you need to intervene when something goes really wrong. For example, let's talk about the easiest thing, CPU levels. I would claim that if a node dies even once a day over 99% CPU levels, something is not configured properly.
Okay,
Something.
so let's take off. You know what? Okay, so just to narrow it down,
Yeah,
okay, because I know a lot of companies and a lot of our customers, maybe back in the day in PodOps, set this alert to be on 90%, and nothing happens to the node. It doesn't die. So let's assume the nodes doesn't die. Okay, like, nodes get to 90% usage, CPU memory utilization, and they don't die. Everything moves normal. Do you need to get an alert about that? That's the main question. That's like,
absolutely not. Absolutely, but that's the idea. That's why most of the things we talk about are, it depends, because maybe you're in an environment that can for like easily tolerate 90% CPU pressure. Maybe it's not, because it depends on the type of the nodes. It depends on the type of applications. Maybe you're running an application that's so CPU intensive, and at some point it gets a peak like every once in an hour because it runs a backend job or a garbage collector or whatever. And that CPU pressure is going to kill your node. Maybe that's not the case. You're running in an environment that is gradually going up and down, or none at all. It's like a flat line, and you're good with it. You can run in 92, 93 pressure levels of CPU or memory and everything. I'm assuming that's not the case because it's really high, but maybe. And if that's fine, no reason to pop an alert. And again, that's where you want to separate your thresholds, because maybe in this case, then your threshold is 98%. Now, it's an extreme. We're
let's
talking,
build rules.
yeah,
Okay, we got a lot of theory over here. Let's build rules together. Let's work together, Omer. Let's work together. We did it back in the day. Let's do it now.
let's do it.
Okay, let's build rules. So I think we have the same, like, we agree. Unfortunately, we agree that we don't like to get an alert for 90%, 95, even 99% CPU memory usage for a node. Again, it's for a node, not for a pod, because for a pod it's meaningful, because then it might say this application is wrong. I want to know about it. Okay,
Yeah.
so this will be interesting to me. But specifically for a node, I'd say if this node, if you are monitoring a node that is a spot instance or a node that you know that can die from time to time, then it's safe to say that this is why we are using Kubernetes and managed services and whatever to deal with high pressure nodes that can then be automatically evicted. So you don't really have anything to do about it. You don't need to get an alert about it. So you should monitor it, but you don't really need to get an alert about it. Okay, so like monitoring and alerting, even though alerts are part of monitoring, I always see it as if monitoring is one thing and getting alerts is other thing, even though it's connected, even though it's related.
Mhm.
Okay, so you should monitor it to get this information in case you will want to investigate it, maybe in the future, maybe get some statistics, maybe sell those statistics, I don't know. But regarding the alert, if you don't have anything to do about it, because you are not going to taint the node and evict it. This is why you're using Kubernetes. Otherwise, why are you using Kubernetes? If you need to do it manually, don't use Kubernetes.
Mhm.
Pay someone to do it for you and whatever. So, like the ground rule for this is for non-critical, okay, non-critical workloads, assuming you have configured everything properly with high availability and I don't know, durability with backups and whatever, then you don't really need to monitor high CPU memory usage for nodes because they're going to self-heal themselves. And this means you're actually using the nodes properly.
Mhm.
I want my nodes to get high CPU and memory. It means I'm not wasting money. Okay? Like that's the rule that I'm saying. Do you agree or not agree? Do you want to fix it, complete it,
100%. I want to allow me to go a little broader. Okay.
enrich it,
Yeah, enrich it. No, it's actually the other way around. I think,
and pour it?
yeah, my process, I think a general process for deciding on thresholds, how much CPU and memory to give an application, how much disk I need for my server, uh, on which level I'm going to alert over a certain level for anything, a node, a pod, or whatever. Usually you have some kind of idea where your starting line, where you start off with. And then gradually, as time progresses, you're going to change things, the threshold of alert, the amount of resources you provide to something. Let's go with alert specific because that's the topic of the conversation. I think most of the alert fatigue in the world comes because of laziness, because you've configured something to pop an alert because you have something in mind, right? I want to know when my server reaches 70% CPU levels. Cool. And then this alert pops the first time. You're going to check something, nothing goes wrong. You're okay with it, especially with Kubernetes, exactly like you so eloquently just said. It works. That's what the cluster does. It's fine. I don't need to know about it, even if it goes to 90. Cool. Um, it's going to keep popping. And if at some point you're not going to apply, the 2 minute rule? There's a 2 minute rule that says if something takes under 2 minutes, do it now. Don't wait with it. You know that? So I'm
No.
trying to apply it with taking the garbage out. But basically, if something takes less than 2 minutes, just do it now. Wait, because otherwise it's going to pile up. I think that's what happens with alerts. There's an alert popping. You already know that you're not going to do anything with it. So it either bugs you and just creates a context switch, or at some point it's going to become so annoying that you're going to mute the channel altogether. What I want to tell the engineers among us is if it takes like 90 seconds to go to the alert and properly configure it. Remove it, change the threshold, add more data points in before it pops an alert, whatever, handle it. So if you see an alert that's not relevant, if it takes under 2 minutes, and usually it does take under 2 minutes, just go ahead and fix it. And then that will help you because you won't have to wake up in the middle of the night because the developer doesn't know what to do because he muted the channel, right? So you're helping
I'm
others.
listening to you as a viewer, and I'm sad because I wish it took less than 2 minutes. You know why? Because we made, DevOps made our lives so much complicated. Think about it, Omer. Maybe in a startup, you can do it under 2 minutes. In an organization, everything is managed in the code. So if you want to change the alert, you can't really go just to Grafana and change it. You need to go to dev, create a PR, have your team lead review it, roll it out to QA, roll it out to production, and go to the beach. So it always ends with going
May
to the
I
beach.
want to remind you
But,
something.
but it's said, think about it. You said it's taking less than 2 minutes. I agree. I totally agree with you. But in real life, it's going to take, what, a week?
Meir, 3 episodes ago, you told me that your view on the world is that in 5 years, under 5 years, AI is going to do all of that for us. So what I'm going to say is maybe in the next 5 years, I think you can already. There are solutions for you to type in natural language in your Slack channel. Hi, Mr. Bot, please change the alert levels on yada yada to these. And there are already commercial solutions that can take care of that for you. So maybe a plan for you with this episode, if you get out with something here, is to apply something like that, and then that will handle whatever it takes, whatever it has involved in that. Create a PR, alert the DevOps team, change the metrics on your own,
I'm just
whatever.
saying, I just pointed out because I'm sad. I'm sad because I think what you said is right. That if it takes under 2 minutes, just go to, the alerts manager or Grafana, just change that and move on with your life. And then I realized that that's not how it works.
So
Like, I need to do a bunch of things to change a simple alert to be better.
that's a
So
perfect point.
and then I'm like, wait, hang on. I have my sprint content that I need to do, or maybe I need to support someone as a DevOps engineer, or I don't know, or maybe developers. Maybe a developer will see that alert and say, I want to improve that. And this developer suddenly hears about the process he needs to go through to change these alert data points, as you said, or whatever, and he'll be like, oh, wait, so listen, I'm going to develop my node application, bye bye.
So here's
You
something to
know?
take away from this episode.
So sad,
If
so
it takes
sad.
you more than 120 seconds to change an alert level, even if you're running in a large organization, maybe that's your first project. Before anything else, make the process so that any developer can either create a request that fixes itself in a matter of a few days, or allow them to make the changes, but create a process that lets people do these things. Because again, if it takes more than 2 minutes, nobody's going to bother in the middle of a
I like
hectic
it. I
work.
really like it. I'm glad you mentioned it. I'm gonna take it to our next sprint and talk it with my team lead. That I'm not sure like what's the process in our organization specifically, but I think every organization should have what you just said. You should also enable it, as platform engineering, you should also enable it for developers. If a developer thinks that, his alert fatigue is too high or too low, I don't know how you look at it, but maybe they will, if you enable them, change alerts, play with it, test it,
You,
and it's not going to take days or PRs or reviews, then it's going to be amazing,
you want a small story? I
Small
think
story.
9 years ago, I don't want to name the company, but I started working somewhere. And for every security group change of a specific port, I had to send an email to a team lead that was on a different group. And that email would only get an answer with a question of why do I even need to change it and when. Usually I'd provide a description which wasn't good enough for them. And it would take about 2-3 weeks to change port 8080 to 8081. And at some point, I just started playing with the same port from the same node to do whatever things I needed. So I would start on the same port, a front end application, then a debugger, then I'd kill that and start something else. The process was so messy that I had to find, and I was in like an ops engineering position. I wasn't a developer. So if I had to work so hard and find my hacky ways around it, which obviously you can all think of what security issues comes up around this, you need to create, the bottom line is create a process that allows everyone to work easily and make changes, obviously safely and in a correct process, quote unquote, but allow people to do their job. That's it.
It's amazing. I think it's a very good, I can't say summary, but eventually, if you want to answer the question that we started
Mm-hmm.
with, like, should I monitor high CPU memory on Kubernetes or on nodes in my cluster? Then, as we always say, it depends. So for non-critical nodes, we can say it's not really important. But if you think it might be important and maybe you want to change that or do something about it, make sure you have the process that is short enough and easy enough, not just for you as a DevOps engineer, but for your developers, or, it depends on the need. Yeah, because you don't want to give developers everything, any permission to do anything. But the process of changing alerts, I think this is what I'm taking from this conversation, that the process of changing alerts should be easy. Even if it's managed with infrastructure as code, it should be easy.
I,
If it's taking time, you're doing it wrong.
I agree, and I want to add something. At some point,
You agree? You said that. You cannot not agree.
no, I agree to the addition. I agree to the addition, and yeah, it would be funny if I wouldn't. at some point, I think you
No
want
sé.
to delegate your work to developers, not in the sense that you're moving responsibilities, but I think the entire idea of DevOps, not to go back to the basics, entire idea of DevOps is having developers do operations and ops engineers do developers work all together. It's a culture, right? Not a job description. So I think developers should be aware of the CPU and memory levels and disk pressure and whatever's going on with their application. If you let them do their work and they can be part of configuration and changing metric level and be part of the alerting channel, and they're the ones that need to fix things when alert pops, then they would care. It would be under their responsibility. And if you give them the luxury of changing things and helping you do your work, but not framing it like that, they're basically doing their work. They build something, they own it, they monitor it, they fix it when they need, then you're delegating your work to someone who is responsible, because you may or did not build the application. You're very good with configurations, you'll probably handle it at some point, but you'll have to do a lot more work because you don't understand the mechanism of the application itself better than a developer that wrote the code. So it should be like a collaborative work.
A collaborative role that brings up a synergy, just so it sounds,
Heaven.
mind blowing. It's a synergy between the DevOps and the dev and the whatever. I think that that's a good summary and concludes our discussion.
Yeah.
And I really enjoyed this conversation. I think I have like 20 more topics to talk with you about after this conversation. Like every time we start, it's like, okay, what are we going to talk about today? And then after we finish the conversation, I have like 20 more topics to talk about. I also have an action item to talk with my team lead about enabling
Metric
how
threshold
to
changes.
configure alerts.
Yeah.
No, yeah, like the process, like thinking about improving the process, or maybe it's already perfect, I don't know, but maybe improving the process of changing alerts, how the way alerts work,
Yeah.
and enabling for
Yeah.
developers, enabling the process for developers. Okay, so are you ready? Because we're gonna sum it up. So are you ready for the corner, Omer?
Yes.
We didn't do the corner for a long time.
Okay, let's
I'm
do it.
excited for the effects. Are you ready?
Yes.
Okay, so corner of the week.
This summer.
Yeah, by the way, I do it exactly like you said, like this summer. This is what I'm thinking about it when I'm saying like corner of the week. Okay, so and then the effect and so today we're gonna talk about, or in this episode, we're gonna talk about the things that Omer did or I did last week, next week, next summer, last summer. What did you do last summer? Or whatever we want to talk about in the corner of the week. So, Omer, what are you going to talk about in the corner of the week?
Okay, do you know .env files? .env. Yes.
Yes, yes,
Do you use them often?
yes,
Cool. So there's a problem for me with .env files. A
I
lot of
know.
problems, but the main one is that usually you probably need to add them to your git ignore because you don't want to push them, because they probably contain some sensitive parameters or secrets. And what I usually do is, one, ignore them. Two, I don't even, and then the secrets they need to be managed somewhere. So there's a really cool project. If you're writing some JavaScript, if you're listening to that and you're writing JavaScript, you probably know of a project that's called .env. That is basically something that's integrated into the framework to pull .env parameters and inject them into the process. The same developer had built a new project that's called .envx, and that's not only for JavaScript developers, it's for everyone. And this allows you to take whatever .env file you have and encrypt it with a key. And then it gives you a simple CLI that takes the parameters, the secrets, whatever you put there, encrypts everything so that you can ignore the key, but you can push your .env safely to GitHub. And then this thing sits encrypted on your main repo. But not only that, it starts the process and reads the variables, decrypts them, injects them into the process. It does the entire process of reading something, keeping it safe, encryption, decryption, injection, all these things around your variables. I'll put a small asterisk. Not necessarily I'm going to use that in production, because at the end of the day, you are pushing something sensitive. One, there's the risk of human error because you are in risk of pushing your private key. So that's something you need to think of. And two, scanners on the internet, security scanners, are usually looking for weird looking strings, to put it in simple words. So you're still pushing something that looks like sensitive data, and then you're going to put yourself under the spotlight. That's what I'm saying. However, that said, it really eases the process. You don't have to look for security managers or password managers. Great for side projects, for anything you're building at home. So you can use .nvex and it does everything for you. That's it. That's mine.
Sounds good. You got me thinking about it. Like before you said about the asterisks, like I thought, sounds great. And then I'm like, wait, I'm not sure I can integrate it in my
So there are
projects. It
solutions you
sounds like
can.
a very
People came up with some nice solutions. You can symlink the private key and then not have it in your repository at all, so you don't have to ignore anything. But again, it's a process, right? So you need to find a process. But again, nothing to worry about. Use that thing; it takes care of everything for you, other than the small risk of you having to manage the key. Oh, sorry.
Do you realize how many times we say, we need to look at the subtitles, how many times we say, then again, it's a process. Then again, it depends. It's like we say it across the whole
Yeah,
episode, like 90% of the episode. Then again, it's a process. Then again, it
there's no
depends. We can have a
perfect.
remix
There's
about
no
it.
perfect technology. That's why technology is always evolving, right? It works to a certain point.
It depends.
It depends. It works to a certain point. Different use cases, different stuff. But
I'm going to enrich your .env. I think that Node added .env natively, support
could
for
be, yeah.
.env natively since Node 20,
Maybe it's
21. You
this
need to
project. It's a
check that.
huge project. I'll look it up on GitHub. But it's
But you're talking about
yeah, not the
.envex.
.nvex,
Yeah,
the
but
original one.
just saying .env is now supported in Node from version 20 or 21 or whatever.
Yeah,
Like they added in alpha in 19, I think. I don't think
makes sense.
something like that. So in case you want to load your .env file, just make sure you're on a high node level and whatever. It's funny because we talked about nodes in Kubernetes, and now we're talking about node in
Nice
TypeScript,
closure.
npm, whatever, Yeah, nice closure. So what I'm going to talk about is probably what I want to talk with you about in the next episodes. So this week, um, I dealt with authenticating between AWS to GCP because I'm migrating from AWS to GCP. Never mind why, I just want to talk about the specific thing. I wanted to access some, let's say, Kubernetes cluster from AWS to GKE. Okay, so from an AWS EC2 instance, I wanted to access a GKE cluster and maybe do something about it, or do, authenticate and do something, maybe delete a pod, or I don't know. You got the idea. So to do that, you usually have two options. Create keys in GKE, provide it to the EC2, and then do whatever. Or you can do the thing that we're gonna talk about it in the next episodes. Not sure which one is the workload identity federation. I love the word federation. Sounds like federation. So we're going to talk about workload identity federation, where I told GCP, listen, you can trust on AWS, trust on this account, trust on this IAM role. I trust it. So when you authenticate my user, my EC2 instance, just make sure you check it with the STS AWS, and then it's okay by me. You can authenticate between AWS to GCP, and what I'm saying right now is valid to most known identity providers or most known cloud providers. So you can authenticate between GitHub to AWS if you want to deploy an application. You can authenticate between a lot of things with workload identity provider and it's a passwordless authentication.
Mm-hmm.
So I dealt with this week, and it's just fun. It was amazing. I just love it. So we're definitely going to talk about
Yeah, I
it
have 20
someday.
questions. I'll keep them
Okay.
for another time.
The first one is, as always, why would you do that, right?
Something like that.
But why? But why? Okay, so Omer, anything else you want to add to this funny episode?
No, that's it for this one.
Okay. So see you next time. It was a pleasure. Thank you everyone for watching, joining, listening, viewing, and no se.
No, sir.
Yalla bye.
Bye.
No se.